Welcome to the world of wonders.
Upbeat, mysterious synth music fades in, then
Ever
under.
look up at that rusty red dot in the night sky and wonder, when will we finally take that giant leap, not just to visit, but to stay? To build a new home under an alien sun. We've seen the rovers, the helicopters, the stunning panoramas. But what comes next? What's the real plan? Welcome back, space explorers. Strap in, because today we're diving deep into what's not so much a secret, but a meticulously planned, staggeringly complex blueprint for humanity's future on Mars. This isn't about hidden bases or whispered conspiracies, it's about the incredible, publicly available science and strategy that NASA and its partners are developing right now. This is the truth about human settlement on the Red Planet. Music shifts to something more grand, inquisitive. Let's start with the biggest question: why? Why Mars? Why go through all this trouble? Well, it's more than just planting a flag. It's about survival, science, and the human spirit. As a multi-planet species, we ensure the long-term survival of human consciousness. A catastrophe on Earth wouldn't mean the end of us. But more immediately, Mars is a time capsule. It holds clues to the history of our solar system, the potential for past, or even present, microbial life, and serves as the ultimate laboratory for geology, climate science, and human biology. Living there would teach us more about our own planet and ourselves than we can possibly imagine. But you don't just pack a suitcase for Mars. The journey itself is a 7-month nightmare of cosmic radiation, muscle and bone atrophy, and psychological strain. NASA's plan, part of the broader Moon to Mars strategy, is to test everything closer to home first. The Gateway, a small space station orbiting the Moon, will be a staging ground. Think of it as a cosmic campground where we learn to live in deep space, test new technologies, and prepare for the longer haul to Mars. Lessons from the Artemis missions on the lunar surface, like using local resources, or living in harsh environments, are direct rehearsals for the Martian frontier. So, let's say we've arrived. The first crew touches down. They won't find a welcoming committee or a pre-built city. The initial habitat will likely be sent ahead, autonomously, using technology like the SpaceX Starship or a similar heavy-lift lander. This first base, it probably won't be on the surface at all. The most discussed idea for an early settlement is to go underground. Lava tubes. These are giant, cave-like tunnels formed by ancient volcanic flows, and they're scattered across Mars. They offer natural protection from the two biggest killers on the surface, radiation and micrometeorites. Inside a lava tube, settlers would be shielded from the constant barrage of cosmic rays and solar storms. The temperature would be more stable. It's a ready-made foundation for a base. We'd seal it, pressurize it, and create a safe, subterranean home. But to be truly sustainable, a colony cannot rely on shipments from Earth. It's too expensive and too risky. This is where the concept of in situ resource utilization, or ISRU, becomes the most important acronym on Mars. It means living off the land. And the most critical resource: water. We've seen the gleaming white ice at the poles and detected vast glaciers buried underground. Mining this ice is priority number 1. Water is for drinking, yes, but when you split it into hydrogen and oxygen, you get air to breathe and rocket fuel to return home or travel across the planet. It's the lifeblood of the colony. Next, the atmosphere itself. Mars's thin air is 95% carbon dioxide. That's a problem for us, but a goldmine for technology. Using a process called the Sabatier reaction, we can combine that CO2 with hydrogen from water ice to create methane fuel and more oxygen. We can also extract nitrogen and argon from the atmosphere to create a more Earth-like breathing mix inside habitats. And the red soil, the regolith. It can be used for radiation shielding, packed around habitats. With immense effort, we might even process it into bricks for construction or use specialized greenhouses to grow food. Speaking of food, forget about open fields. Martian agriculture will happen in highly controlled, sealed environments. LED lights tuned to specific plant needs, hydroponic or aeroponic systems that use minimal water, and recycled waste as fertilizer. Every gram of organic matter will be precious. Early diets will be heavily plant-based, perhaps supplemented by lab-grown proteins or insect farms, which are incredibly efficient. It won't be glamorous, but it will be nutritious. Now, life inside this colony. Imagine a day. You wake up in a small, private quarters carved into the side of a lava tube. The gravity is only 38% of Earth's. You'll bounce out of bed, but you must do 2 hours of rigorous exercise to prevent your bones and muscles from wasting away. You put on a comfortable jumpsuit, the air is clean and smells faintly of recycled metal and soil. You walk, or bounce, down a corridor to the common area, passing large screens showing live views of the stark, beautiful Martian surface outside, or perhaps a simulated forest from Earth. Your work could be anything: maintaining the life support systems, tending the vertical farm, conducting geological surveys in a pressurized rover, or analyzing data from drones scouting new territory. Communication with Earth has a delay of up to 20 minutes each way, so real-time conversation is impossible. You're living with a small, intensely trained crew. Conflict resolution and psychological stability are as critical as engineering skills. This brings us to the biggest challenges, the true secrets of the plan that keep scientists up at night. Radiation is a constant, silent threat, requiring innovative shielding materials or even genetic research into human resilience. The perchlorate salts in the Martian soil are toxic and would need to be carefully removed from any systems. And then there's the social and ethical dimension. Who governs? What laws apply? How do you handle medical emergencies or even births? These are questions without easy answers. This isn't a solo mission for NASA. The current vision is a global one, involving partnerships with private companies like SpaceX, Blue Origin, and others, as well as space agencies from Europe, Japan, Canada, and more. SpaceX's ambition for a self-sustaining city of 1 million people is the boldest endgame, pushing the entire industry forward. NASA's role is often to do the foundational science, the riskier early missions, and develop the standards that keep everyone safe. Music swells, then becomes more hopeful and forward-looking. So, is there a secret colony plan? Not in a locked vault. But there is a breathtakingly ambitious, step-by-step roadmap being drawn in laboratories, mission controls, and engineering bays across the planet. It's a plan built on incremental testing, from the International Space Station to the Moon, and finally to Mars. It acknowledges the immense hardships but is driven by an even greater hope. The first settlers won't be going for the view. They'll be going to work. To build, to sweat, to struggle, and to lay the foundation stone for a new branch of human civilization. They will be the most isolated humans in history, and also the most connected to the future.
Welcome to the world of wonders.